parentheses, then exponents, then multiplication, division, then addition and subtraction. Now, when you have like multiplication and division in like we had here, you do it left to right. So even if division comes before multiplication, you do whichever one comes first. Same with addition and subtraction, you do it left to right. Does that make sense?
Yes.
Okay. All right. So let me give you just a slightly more difficult problem here for you to look at without multiple choice. Now, are you typically allowed to use a calculator in your classes?
I don't think so. Like, I haven't been told I could.
Or could not? Okay. All right. So yeah, just here's one for you to try. I'm just gonna step away for 30 seconds. Sometimes I gotta do that because I'm at home, I got stuff going on that I gotta just tend to, plus you're working on the problem. So just give me 30 seconds, I'll be right back to check with you.
Okay.
All right, I am back. If you have some questions or you got the answer, that's also good.
Right. I was just writing it out, so I'm
Sure.
just
Good strategy to write it out.
89. Would the answer be 89?
9 like that. Good. Okay, so let's take a look here. So 6 plus 3 is 9. 9 squared is 81. And we got 9 minus 10 divided by 5. So you got to divide first. That's 2. 9 minus 2 is 7. I've got a slightly different answer. Where do you think you went different from me in that? You see where you're slightly different.
Oh, I just added incorrectly. So 88.
Okay. Okay. And that could be just a function of, hey, I've not done math in a while and I just, I'm in the summer mode. Did you get a summer break? Or not?
Yeah, I did.
Okay,
But
good.
I kind of been working on math during it, but just not.
Yeah, it's like anything else. Sometimes you gotta, takes a little while to get things going again. All right, so here's a new question for you to look at. It's kind of related to order of operations. So I'll just throw it at you and see what you come up with here. You may find that you already know how to do this, but give this a try, please. And
32.
you're correct. Good. How would you rate the difficulty of that question for yourself?
That wasn't hard to figure out.
Okay, I like hearing that. 'Cause what I'm trying to do here is gradually increase the difficulty and then the concepts for you so that, it's not just like being hit over the head with the most difficult stuff. And I can tell I'm probably not challenging you enough with this. So let's move on here to something else. Just a couple of equations to solve. No answers this time. I know that's often more difficult. When you solve, you can pick which one you want to solve. We may do both, but just pick one, solve it, and let me know if you have any questions for that.
Okay. I guess I'll just do the first one.
Okay.
So I'm just trying to figure out what M is.
That's, so this is one of those where, um, because I'm not giving you the answers, you can't just try them. You have to actually work it out, which is, this gives me an idea of what you have seen or haven't seen. These are considered two-step equations.
Okay. Hmm. So should I try to solve the first one?
Yeah. Yep. Yep. I'm just like, and if you're like, hey, I don't know how to do this, I've never seen this before, that's fine too. I'm trying to gauge, where you're at so we can pick a topic and kind of dive into it.
Mhm.
This may be it. All right. So let me I can just tell this isn't going to go well. So let's start with just one step equations. Okay.
Okay.
Let's just build a lesson from this. This will be a good place to start here. So there are four math operations that you know about: addition, subtraction, multiplication, and division. Okay. And they are undone, or you undo them with the following. You undo addition with subtraction, subtraction with addition, multiplication with division, and division with multiplication. Okay. So you undo addition with subtraction, subtraction with addition, multiplication, division, and so on. So if I give you a problem like this, x plus 5 equals -2, you look at the side with the variable. Okay. Now you may already know the answer here, but we're doing this in the context of like how to solve one step equation. What do you see here? Tell me what you see to the right of the variable. What is this that I'm hovering over, highlighting?
5
Plus 5, addition by 5. How do you undo addition?
subtraction.
Subtraction. You subtract 5 from both sides. Have you seen this before?
Yes.
Okay. What is -2 minus 5?
7
Try
or
again.
-7.
-7. Yeah. Okay. Great. All right. So let's look at another problem. Let's say it's 15 equals W minus 3. Okay. So you always look at the side with the variable. Do you know what I mean by side in this context?
Yes.
Okay, so there's a left side which has got 15 left of the equals, a right side which is W minus 3. You look at the side with the variable. What is going on here to the right of the variable? What do you
Um,
see here?
-3 subtraction.
So you undo subtraction with
Addition.
addition. You add 3 to both sides. Now you'll notice the way I do it is I write it right underneath both sides. I always draw this line here. It's like a total. total line. You'll see this in accounting. If you ever get into that someday. But the point is, it's kind of like a step. You're like, all right, we're done. So what is 15 plus 3?
18.
18 equals W. Okay, now this is a little awkward. Okay, because usually you want the variable on the left.
Mhm. Okay.
Okay, we read left to right. We write math equations left to right. It should be read W equals 18, not 18 equals W. Now, is what I have here wrong? No, it's not wrong. It's just awkward. I mean, for lack of a better word. And W equals 18 is preferred. There's a lot of analogies I can make to real life. I didn't really ask you much about yourself, which I usually do in the first lesson. I apologize. Just kind of try to get to know the customers a little bit. Like things you like to do to help, kind of like match it up. But a couple more examples here. So let's say it's like 5x equals negative 20. Okay. So you look at the side with the variable, side with the variable. What do you see on the side with the variable? What's going on here?
Multiplication.
Multiplication. So when they're squeezed together, when the variable and the number are squeezed together, I call them, that's the language I like. I mean, I don't know, they're squeezed together, they're touching, whatever. That's multiplication. So you undo multiplication with division. Now we use a fraction bar. You use a fraction bar instead of the division operator.
Mhm.
Okay. And x equals minus 4. Like that.
Okay.
All right. So the last one is what if it's like x divided by negative 2 equals negative 3? Okay. So how do you undo division?
Multiplication.
Multiplication. So you multiply everything by negative 2. By whatever number you're dividing by is what you multiply by.
Mhm.
So tell me the answer. What is the result of this multiplication over here?
Um, 6.
Okay, you seem a little uncertain. I would like a little more confidence in your answers. Do you have a question about that, or you just
Well, so usually, isn't it like if there's two negatives, it will equal a positive?
yes? So let's talk about some rules. Rules for multiplication and division. Okay, so if you have a positive times a positive, these are considered same sign. It produces a positive. A negative times a negative produces a positive. Do you see how these are same sign?
Mhm.
Okay. Now, what about a positive and a negative, or a negative with a positive? These are considered opposite in sign. They both produce a negative.
Okay.
So you have to know this. You have to be able to roll out of bed in the morning. You have a phone. Most kids your age have a phone. I'm just asking.
I
You know
don't.
your phone number. And you know your phone number.
I don't have a phone.
Oh, you don't have a phone. Okay. All right. Bad example. You know your address. So you roll out of the bed in the morning. You know your address, right? You could rattle off your address. Like that's how well you need to know this. There can't be any questions about this. Okay, because it leads to a lot of problems in this course and others. And sometimes that's the reason students struggle is they just haven't spent enough time doing this. Now, this applies to both multiplication and division. So for example, if you're dividing, if it's a positive divided by a positive, that becomes positive. If it's a negative divided by a negative, it becomes positive. If it's a negative divided by a positive, it becomes negative. If it's a positive divided by a negative, it becomes negative. So it's the same rule. If they're same sign, it's positive. Same sign, it's positive. Opposite in sign, it's negative. Opposite in sign, it's negative.
Okay.
Like it's almost more work for me to write it out than to just say the rule. Okay. But here's the thing. Let's just say I give you a problem like this: -2 times -3 times -5. Okay. The first two, -2 times -3, you just told me is 6, right? 6 times -5. What is 6 times -5? It's negative 30. Do you follow that, how I did that?
Yeah,
And the idea is like you can't like you could try to create rules, but you just want to do it in pieces. If they're two negatives, it makes a positive, and the positive times negative
negative.
makes a thing. Yeah. So another example would be like, let's say it's negative 80 divided by negative 8 divided by negative 4. Okay. You would do this. Actually, sorry, let me write a number. Let's go negative 2. Negative 80 divided by negative 8 is what?
10,
And 10 divided by negative 2 is what number?
-5.
Negative 5. Good. Okay. So you got it down. All right. Okay. So let me give you a couple of one-step equations here just to see where you're at. Let's go negative 4 equals W minus 1. Let's see here. Negative 2x equals negative 20. W divided by negative 2 equals 5. And then x plus 1 equals 1. So have you try those four, please, and uh give me your final answer.
All right. Do you want me to just do that on notebook?
Sure.
All right. Okay. So for the first one, would that be -3?
So you have to read it as a like variable equals like I did in these previous ones. Your final answer is like x equals 6. That's how you want to read it to be.
Okay, so W equals -3,
Good.
and the one below that, X equals 10.
Good.
Top right one is W equals -10.
Okay.
The last one is X equals 0.
Good. Okay. So one-step equations, there's a few variations on this that I'll show you now. Like if I write negative 4 plus v equals negative 3. This is it's on the left here is really subtraction by 4. Do you see that? Like, do you agree with that? It's not like this plus goes with the v.
Mm-hmm.
Okay. So you would add 4 to both sides here. V equals 1.
Mm-hmm.
Does that make sense?
Yes.
Okay. Um, other ones you might see is like let me try to think here. Um, negative x equals 5. Okay. Whenever you see a negative, that really means what this really means is -1x equals 5. So you undo multiplication with division, you divide both sides by -1, x equals -5. Have you seen that before?
Um, I'm not entirely sure.
Okay. What I'm trying to show you is that like sometimes you'll see a negative in front of a variable, but it really means it's -1 times the variable.
Okay.
And that's important. Like it seems like a small distinction, but it really isn't. Like it's a big deal. Um, to recognize that. Like, and maybe more generally, like maybe you didn't notice, but when you say like x equals 2, you're really saying 1x equals 2. Like that's what it really means. But the thing is we don't write the 1. And you might wonder why. We could get into that. But let's just say you're like, okay, well, there's a 1 there, and you divide both sides by 1. What is anything divided by 1?
One or the uh same number.
It's the same number. So that's one reason why you don't write it.
Mhm.
Okay, you write it as, x equals 2, 1x equals 2 is the same. It's kind of like if you make 4 right turns, you get back where you started. So you don't need to write the 1, but you need to know that it's there. But when there's a negative, it's really -1.
Okay.
All right. I know this isn't super interesting. I'm trying to cover all the cases so you don't get something weird. There. So another kind of question you might see. So let's say it's something like this. It's like W divided by 7 equals -5. How would you solve something like this based on what we've talked about?
Um
What are you trying to undo? Or what's the math operation that you see?
uh on the left I see division,
Yeah. So how do you undo division?
multiplication.
You multiply by 7, right? This is W equals -35 is your final answer. Is that okay?
Okay, yeah, I see.
Okay, so and that's important because you might also see it written like this: 1/7 times W equals -5. Okay. Now, really what this is 1 times W. Give me just a moment here. I'll be right back with you.
Okay.
All right, Hudson, I'm back here. Not sure where we left off. What I was trying to show you is that you would multiply both sides by 7 to
Okay,
undo 1/7. So W still equals minus 35.
all right.
Okay, so we're moving into now what are called two-step equations. And two-step equations require you to do two steps. Typically you undo addition and subtraction before multiplication division. And if you haven't figured it out by now, math is full of exceptions. Okay. I don't know, have you heard that before or not?
I don't
You don't think
think
so? Okay. Yeah, a lot of students, they'll say things like that to me. They'll say, oh, there's all these, and they're right. They're right. There really are things that you're just like, oh my gosh, like why is this so different? And there are exceptions, truthfully, to everything. But here's an equation. We're just gonna look at a very basic problem here. This is kind of where I wanted to go, and we had to just take a step back to 1 steps. So here we go. 4x minus 5 equals 3. Okay, 4x minus 5 equals 3. How do you undo subtraction over here on the left?
addition.
Addition. So you're going to add 5. So that's what I meant by you undo addition and subtraction first. You're going to add 5 to both sides. So 4x equals
Oh, 8.
8. And now the 4 is multiplying the x. So you undo the 4 by dividing by 4. Multiplication by 4 by dividing by 4. X equals 2. Like that.
Okay.
Does that make sense?
Yes.
Okay. So what I typically do here, and you've kind of been doing this already, is I put a problem up just like it right here. All I've done is change the numbers. Now, what's important here isn't that you can do it in your head. It's that you write it out and work it out the way I've done here so that you build the correct patterning of how to do these problems. So give this a try, please.
Okay. Okay, so I got x equals 8.
All right. Back. What did you get an answer for this?
I got x equals 8.
So you're adding 5 to both sides. 3x equals 24, divide by 3, divide by 3, x equals 8. Very good. All right. So some other variations on this that you will see. Let me just grab a problem here or two for us to look at. The variable could be on either side. Okay. The variable could be on the left, it could be on the right. In this case, it's on the right. You see that? So your focus is always on the side with the variable. That's for some reason that's not made clear in the classroom, but you look at the side with the variable. So you're like, all right, I just care about the right side. And you can see there's subtraction by 1 and multiplication by -3. So how do you undo subtraction by 1?
Addition.
You add 1 to both sides. Okay, so what is -13 plus 1? What does that become?
12.
-12. and then minus 3z. So you gotta be very careful with your signs, right? Like we can talk about the rules there. But it's good if you remember, what's going on. So -3 times z, how do you undo -3 times z?
Division.
Division, you divide by -3. So you divide by whatever number is in front. And so the number is -3. So if it's, whatever it is in front as you divide by.
Okay. So would the -12 divided by -3 not become positive
It
4?
is, it does becomes positive, it
Oh.
becomes +4. And then you've got this issue again where the variable's on the wrong side. So you flip it z equals 4 like that.
Mhm.
So if you don't have this down in your notes, I would write it down because I'm gonna give you a problem like it to try. That's always kind of the best way to gauge, your understanding, just to see, okay, here you go. Try one, see if it works. Things like that. Let me know when you're ready and I'll snip one in here for you to try.
Okay, I'm ready.
Another thing, I mean, the variables can be other things than x, x just happens to be the one we use the most often, but it really could be any letter here. So, all right, so go ahead and give this one a try, please. And let me know if you have any questions and we'll,
Okay. Okay, I got f equals -3.
like that.
Mhm.
All right, yes, you add 5 to both sides. -24 equals 8f, divide by 8, f equals -3. Very good. All right. So you kind of getting a sense of these problem sets that we're going to do. And just keep in mind the lessons are 50 minutes. They're not a full hour. It's good for both me and you because sometimes it does become too much math in one setting. So some other types of problems you'll see again here. Again, a new style of problem here. You always undo addition and subtraction before multiplication and division. Okay? So on the side with the variable, which is the left side, side with the variable, which is the left side, you undo 3, addition by 3, okay, 3 is being added, not because of the plus there, because there's really a plus in front that's not written. Does that make sense?
Mhm.
Okay, so you undo that by subtracting 3 from both sides.
Mhm.
So 2x equals minus 12. And then you undo multiplication with division, so x equals minus 6, like that. Is that okay?
Yes.
All right, so here's one on the right to try.
All right. Okay, I got x equals -7.
Okay, I believe that is correct. You subtract 2 from both sides. 4x equals minus 28, divide by 4, x equals minus 7, like that. All right. I don't really have enough time to go through anything new, but I that's kind of where we're going here. Why is this not? There we go. So I mentioned this earlier, and it really comes into play in this problem. This is kind of where we'll leave off here with our lesson is this is -4 equals negative x plus 7. So one of the things you have to see here is that this is really -4 equals -1x plus 7. Okay, it's negative x, really -1, like we talked about, because when you undo addition subtraction, this negative is multiplying the x, the 7 is being added. So you're going to undo addition and subtraction first, meaning you're going to undo the 7 by subtracting 7.
Okay.
So we got -11 equals -1x. Okay,
Mhm.
and then you undo -1 by dividing by -1. So x equals 11.
Okay.
So let's close out here with you trying one that's really, really similar. Have you try this one here, and then we'll close out for the day.
Having a little trouble figuring out this one.
Sure, yeah, so let me finish that up for you. So you subtract, so it's really -1x plus 3 equals 8. You'd subtract 3 from both sides, that's -1x equals 5. Divide by -1, divide by -1, x equals -5. So like I said, we'll just pick up there next time. We got a lesson, I believe, on Monday. I'm gonna go ahead and stop the recording.